everybody, today we're going to talk about Pythagorean trig identities. We're going to start with one identity. This one identity can be turned into 9 different versions. I don't want you to think you have to memorize these 9 versions. I want you to know the one identity that really has 3 core versions and then be able to manipulate those 3 core versions to come up with the 9 versions all together. To establish the first identity, we're going to go back to a circle with a radius of r, an angle of theta, and a point xy. We'll turn that into a triangle with a base x and a height of y. We know from the Pythagorean theorem that x squared plus y squared is equal to r squared. This is an important piece in the development of our identity. We know that sine of theta is y over r. We know that cosine of theta is x over r. Let's take a look at sine squared theta plus cosine squared theta. To start, we know that's going to be y over r squared plus x over r squared. We can expand that to y squared over r squared plus x squared over r squared. Luckily, we have a common denominator. This means we have y squared plus x squared is r squared. Looking back at our original Pythagorean theorem that x squared plus y squared is r squared, lets us write that y squared plus x squared over r squared is really r squared over r squared, which we know is 1. What we found here is our first Pythagorean trig identity. Sine squared theta plus cosine squared theta is equal to 1. This is the core identity that will lead to the additional 8 versions to give us 9 Pythagorean trig identities. If we solve sine squared theta plus cosine squared theta equals 1 for sine squared theta, we get that sine squared theta is equal to 1 minus cosine squared theta. If we solve sine squared theta plus cosine squared theta equals 1 for cosine squared theta, we get that cosine squared theta is 1 minus sine squared theta. If we divide each term of sine squared theta plus cosine squared theta equals 1 by cosine squared theta, we'll get that sine squared theta over cosine squared theta is tangent squared theta, cosine squared theta over cosine squared theta is equal to 1, and 1 over cosine squared theta is secant squared theta. We can solve this equation for tangent squared theta and get that tangent squared theta is 1 minus secant squared theta. We could also write that 1 is equal to secant squared theta minus tangent squared theta. We could also divide sine squared theta plus cosine squared theta equals 1 by sine squared theta. Sine squared theta over sine squared theta will be equal to 1. Cosine squared theta over sine squared theta will be cotangent squared theta, and 1 over sine squared theta is cosecant squared theta. Solving for cotangent squared theta, we'll get cotangent squared theta is cosecant squared theta minus 1. We could also write 1 is equal to cosecant squared theta minus cotangent squared theta. In summary, sine squared theta plus cosine squared theta equals 1 is our main Pythagorean trig identity. Focus on the major 3 Pythagorean trig identities. As long as you know those, you'll be able to come up with the other 6 anytime you need them.